Now, in this lecture, let's understand why the crash occurs when the bug macro is called. For let's take a look at this source code, the why crash occurs when the bug macro is called. If you take a look at this function, and you can see the bug function is called. What is bug function? And bug is macro type of the function that is architecture specific. So if you compile this source code using the ARM compiler, and compiler will generate the assembly instruction that is specific to ARM architecture, such as ARM version 7 architecture or ARM version 8 architecture. If the same code, this bug maker code is compiled with RISC-V compiler, then compiler generate another assembly instruction that is only executable in RISC-V CPU, meaning that it will compiler generate some RISC-V specific instruction. So when the bug macro is called, and then CPU core will throw the exception. So I can say that bug macro is architecture specific API that force the exception. And if you glance at this code, you may have the question like this: why bug macro function is called inside this function? So bug function can be used just like you call the panic API. And if you think that some of the condition or some of the routine is performed in failure condition, you can add bug macro. So if you take a look at this code, and this condition is considered the failure condition inside this function. So every time you suspect some of the routine, that routine is, if the routine is executed under failure condition, you can add bug macro. Another reason why we can add the bug macro to your device driver is to have the memory dump or force the kernel crash to identify the failure condition by forcing the crash. Because if the bug macro is not called in specific scenario, sometimes it can produce another unexpected side effect. And then sometimes you may go through a lot of the unexpected signature. You may go through some of the issues that make you hard to debug the signature. So for this reason, if you add this bug macro in the critical condition, if you capture a log or memory dump by forcing the kernel crash, and then we can have the much more better debugging information by forcing the kernel crash. That is the main reason why bug macro can be added. Now that I thoroughly explained it about why bug macro can be added, so I explained about the mechanism of the bug macro, and then let me show you another signature when the bug macro is called. And whenever bug macro is called, the kernel log displayed identical paths of some function. In this case, location of the file is debug page log, and line is 81. And then you can check on several signature when the bug is called. Then let me introduce and show you another signature when the bug macro is called. As I told you in the last slide, and bug is architecture specific macro. Then bug macro can be compiled in different way depending on the type of compiler. And in this case, bug macro is called in arc86mm tlb.c, and this signature identify that, and based on Intel architecture, and then after bug macro is called, and it cause kernel crashes. And this kernel log indicate several critical signature, and when the bug macro is called, then it will show the name of the process. In this case, name of the process is worker thread. Worker thread is one of the most famous kernel thread running in Linux kernel, which is responsible for taking care of the data structure of worker queue subsystem, and it is responsible for executing work. Then you can identify the number of CPU core and PID where this process was running. And I'm going to show you another signature when bug macro is called. This signature reveal another important information. So arc parse IC, this is the name of the CPU architecture. So I can say that bug macro is CPU architecture specific assembly instruction. So you will identify the similar signature if any code was running that is located CPU architecture specific directory.